Hello, statistics and pre-calculus. Questions yesterday about when do you take your restrictions and how does that affect the graph? The important thing is that you do take the restrictions right at the beginning, like a couple of people. I think Bridget was one of the main people who said that. And so we're going to show why, see why it comes out, see how they behave. So here you go. How does simplifying affect the properties of a graph? We have three functions here, and they all look like they ought to be the same as I'm looking at this. I've got x minus 2 over x minus 6. Here I have x minus 2 times x minus 4 over x minus 6 times x minus 4, which you say, ooh, look, I can simplify and it would be the same. And the third one you have h is, if I do the division, x minus 2 divided by x minus 4 times x minus 4 over x minus 6. Do the cancellation again. And it's the same as x minus 2 over x minus 6. Same as before. They're all looking exactly the same. What's important about their restrictions is getting them on time, getting them at the beginning. Here we have x cannot equal 6. Here we have x cannot equal 6 and x cannot equal 4. In the third one, we have x cannot equal 4 because it's in the denominator in the original. Ooh, it ended up a different color. And also there's an x minus 6 in the denominator later, so x can't be 4 or 6. Same restrictions as the second one. Indeed, it's the same equation as the second one. Also, looking at the properties of the graph. This one has an x-intercept when x is 2, so 2, 0. It has a vertical asymptote when x is 6. The second one, likewise, because there's an x minus 2 in the numerator, has an x-intercept at 2, 0, and a vertical asymptote at x equals 6. But it also has a hole at x equals 4. More about the y-coordinate of that hole in just a second. Well, about a minute and a half, but there we go. The third one has the same information as the second one. Has an x-intercept at 2, 0 because there's a 2 in the numerator. Has a vertical asymptote at 6, x equals 6 because of the x minus 6 in the denominator, and has a hole when x is 4 because of these. Let's take a look at the graph. Here's the graph of x minus 2 over x minus 6, and you see it does indeed have an x-intercept at 2, 0, and it does indeed have a vertical asymptote at x equals 6. No surprise there. Here's the graph of the version with an x minus 4 in the numerator and denominator. You will notice that it looks exactly the same. Turn it on, turn it off, turn it on, turn it off. It looks exactly the same. Likewise, this one is exactly the same as the red one. So, the difference is when it's on, you do not have a point when x is 4. X is 4 and it's undefined. You notice even thus the icon turns to a hole, turns to an unincluded value. It's called a removable discontinuity once you get to calculus next year because you don't even notice it. If because of the pixels here, if we weren't looking for it very specifically, you would not see it. It doesn't exist on this one. There's not a hole on this part of the graph. When you get to 4, it's the point 4, negative 1. It's the same. These two functions are exactly the same as each other except when x is 4, which is actually going to be a key concept in calculus next year too. These two functions are exactly the same function. The only difference is when x is 4, and at x is 4 there's a hole. Now you're looking at that hole and you can say, hey, it appears to me that the coordinates of that hole are 4, negative 1. It looks like 4, negative 1, even though it's 4 undefined. And in fact, it was 4, negative 1 on the original equation, and that's where you can come back and find it here. What are the coordinates of the hole? You have a hole, and when you're looking for where that hole is at x equals 4. But now these cancel, and so y is going to be 4 minus 2 over 4 minus 6, using the x as 4, and using what's left of the equation after you cancel it out. So the y-coordinate is going to be negative 2, sorry, that's positive 2, over negative 2, which is negative 1. So the hole is at 4, negative 1, which matches exactly what we thought from the graph. When we looked at the graph, the hole was at 4 and negative 1. It looks like 4 and negative 1, and when you're close to it, when x is close to 4, y is very close to negative 1. You see it's a slightly more than negative 1 here, it's slightly less than negative 1 here. In between, it's approaching negative 1. So very cool. Good questions here.